Let's take a look. This is an iPhone 14 Pro in purple. Judging solely from the external appearance, this phone shows no signs of heavy impact or bumps. Let's plug in the charger to check. We find that it responds to charging. The screen also lights up, but the lower part here has turned white. It's very clear the screen has indeed suffered a heavy impact, but the fan described it as just falling from a bed. Buddy, can I ask, how high is your bed? After charging for a while, the phone successfully lights up with the Apple logo, and the phone can boot up normally. We still need to test all the other functions of the phone. Let me ask you a question. What phone do you have? And what's wrong with it? Finally, let's go to about this phone to check. It's a 256GB Chinese version iPhone 14 Pro. Additionally, we'll notice that the earpiece area on the iPhone 13, iPhone 14, and iPhone 15 Pro series is particularly prone to collecting dust because its earpiece grill design is located below the screen, meaning it's inside the phone's chassis. Again, it's also normal. Okay, so why are phone screens becoming more advanced, with more and more features, yet they are less drop resistant? Those who have watched up to this point are true fans of the channel. Don't forget to double tap on the screen and give me a like. You've worked hard, thank you, to understand why phone screens are not drop resistant. We need to learn about the history of phone screen development. Actually, most people probably first started using mobile phones during the Nokia era, but phones back then were only used for calling and texting. The screens on phones at that time could only display black and white. Later, Nokia launched phones with color screens, but the color screens back then were limited by cost and application, and consumers didn't know what the use of a color screen was. Let's open up this iPhone 14 Pro. Let's take a look. We confirm this is the first time the phone has been opened. It has not been disassembled or repaired before. Let's look at the earpiece section. There's indeed a lot of dust. You can see the earpiece grill part is inside the chassis. The screen side also has a lot of dust. After about half a year or a year of use, this area will accumulate a lot of dust. Let's continue talking about the history of phone screens. The first generation iPhone changed the industry's layout, which was mainly based on physical buttons. Apart from the volume, mute, and power buttons, there was only one functional button, the home button. Simply put, with the first generation iPhone, most operations could be completed just by using the touchscreen. Of course, besides promoting the development of phone screens, the first-gen iPhone's overall design and button layout also set the tone for the future industry for early touch screens. The mainstream models and the widely available high-copy phones, knockoffs, almost all used resistive screens. They relied on their pressure sensors for feedback, but because resistive screens had poor accuracy and slow response, they were gradually phased out by the industry. Later, there was another widely known change in phone screens. Fully laminated screens gradually replaced non-fully laminated screens. Let's look at this iPhone 14 Pro screen. Its flex cables are connected at the bottom of the screen on non-fully laminated screens. The touch layer and the display layer are separate. There is a gap between them, which can let dust in over time with long use. Later, there was the major competition between LCD and OLED screens. LCD stands for liquid crystal display, which is what everyone commonly calls a liquid crystal screen. It does not emit light itself. It needs a backlight to shine through it to light up the screen. The shortcomings of LCD are particularly obvious. The panel is thick. It cannot produce pure black. It has poor flexibility, and both brightness and contrast are relatively average. OLED does all these things better. It contains light-emitting diodes itself, allowing for single-pixel self-illumination. The screen can be made very thin. Moreover, OLED screens can provide more vibrant display effects and have faster response times. We will clean this fan's earpiece grill and also clean the dust around the earpiece grill. So now the mainstream models all use OLED, including this current iPhone 14 Pro and the newly released iPhone 17 Pro, iPhone 17 Pro Max. Therefore, the screen is very, very thin, coupled with the fact that the screen is made of glass material. It is not drop resistant, as you all saw with this phone. The outer glass is actually completely intact. In fact, the purpose of the outer glass is to protect the inner screen, but the outer glass on this phone did not serve its protective function. We take out the original, brand new, genuine factory screen. This screen has its own serial number, equivalent to a person's ID card. Let's take out this screen. Original, brand new, genuine factory screens come with a set of new screws and have a serial number. These are the new screws. Then we take out the screen. Original, brand new, genuine factory screens come with their own sensor flex cable. There is no need to transfer the original phone's flex cable over. We configure this screen to the phone and sync it to Apple servers through a later diagnostic process. After cleaning the chassis, we proceed to install the brand new, genuine factory screen. First, connect the sensor flex cable. Then connect the display and touch flex cables, as well as the battery flex cable. Clean thoroughly and install the metal bracket. Use the brand new screws from the box to fix it in place. Actually, when our phone falls, the screen and the back glass bear the brunt of the impact over the largest area. The next fixed areas of the four corners of the frame, and since both the phone screen and the back are made of glass, and they have a large surface area, so when it falls, if the ground is uneven or the point of impact is not uniform, it can cause damage to the screen or the back glass during our use. It's best to apply a tempered glass screen protector and use a phone case to protect our phone. Remove the protective sticker from the waterproof adhesive. Remove the protective film from the screen surface. Close the screen. We place the phone in the sealing and pressure tool for the process. After successful sealing, take out the phone. Install the two bottom screws. Because we replaced it with a brand new, genuine factory screen, we need to press both volume up and down buttons simultaneously while plugging in the charger. Wait until the logo lights up, then release the buttons. The phone will enter the configuration diagnostic program. We click start, then connect to Wi-Fi. Click agree. After that, the phone waits in an initialization state. We go to the computer side and click configure. At this point, Apple's configuration diagnostic program will configure this screen to the phone and sync it to Apple's servers. To put it plainly, it's to eliminate any non-genuine part warnings and have Apple's servers recognize this screen. Finally, we simply boot up the phone. After booting, you will find there are no non-genuine screen part warnings, and the phone's True Tone display can be turned on and off normally. Going to the phone's General About, it will prompt that the display is a genuine Apple part. Similarly, you can check this phone's screen repair case on the official website. Clicking into it will also show that this iPhone's display is a genuine Apple part. After replacing the screen, we still need to test all the functions once again. We notice the mute switch has a lot of dust here. This might be why the iPhone 15 series no longer uses this spring-loaded type of mute switch. We'll clean this dust for the fan. There's also a lot of dust around the volume buttons. We notice the microphone mesh and speaker grill also have a lot of dust. We'll clean them all thoroughly. Finally, thank you for watching. See you in the next video.